Welcome again, everybody, to our virtual demonstration. In a few minutes, I'll be introducing Joy Onash to you. My name is Pam Eliason. I'm with the Toxic Use Reduction Institute, and I'll be moderating this virtual demonstration. We are asking that everybody stay on mute, and if you could please turn off your video. It allows us to focus in on the speakers, our presenters today. We are recording this, and we will make the recording of this demo available afterwards on our website, and you'll all get information on where to find that. Let's see, I will be monitoring the chat. Please feel free to ask a question as it occurs to you. I will be keeping track of that and making sure that we get those questions to our presenters at the end of their presentation. Let's see. So I think that's it. I'd like to introduce Joy Onash. She's the manager of our industry and small business program here at the Toxic Use Reduction Institute. Joy's been with us for a decade or so. She's one of those people who is a doer, and she's a fabulous resource. For those of you who know her, you already know that. For those of you who don't know Joy, get to know her. She's a wonderful resource for you. So Joy, take it away.
Thank you, Pam, and thank you everybody for joining us. Welcome to our second virtual demonstration event. This is something that we usually do in person, but with the way things are, with the pandemic, we are trying to do what we can to provide resources for industry in Massachusetts and across the nation to share information and share stories about what we've been able to do with helping industries reduce the use of toxic chemicals. So with that, I'm going to give a short presentation to let people know about TURI if you're not in Massachusetts, or give more information to those of you who are already familiar with us in Massachusetts. I'm sharing my screen now. We're going to talk a little bit about what we've done and our resources at TURI. So for those of you outside of Massachusetts, TURI is part of the Massachusetts Toxic Reduction Program under the Toxic Use Reduction Act that was adopted in 1999, so it's been around for quite a while. We have some significant goals that have already been met with regards to helping industry reduce the use of toxic chemicals, but we continue to strive to help reduce the use of toxic chemicals in any way that we can. But we like to help Massachusetts companies and communities reduce the use of toxic chemicals while also maintaining a competitive advantage. So with every project, every way that we assist people, we always make sure that it's going to help them economically as well. We don't want to push them towards an alternative that is neither going to work for them nor work for them financially. So those are very important aspects of any analysis and any projects we do with industry. So part of the Toxic Use Reduction Act and the program is that companies must report on the amount of toxic chemicals that they use. They need to conduct toxic use reduction planning, and every 2 years assessing what options are out there in good faith. And they also need to pay an annual fee, and that in turn is what supports our program to provide assistance to industry, small businesses, as well as communities. So the core principles of toxic use reduction, I won't go through all of them, but really just the whole principle is to reduce the use of toxic chemicals at the source. And that way we don't need to worry about the exposure issues, the waste generation issues, and all those other elements that come along with using the toxic chemical if we simply are able to avoid it in the first place. And there are 6 TUR techniques that we focus on. Pam, who you just met, teaches the Toxic Use Reduction course, which allows people to become certified toxic use reduction planners. And to learn in that course about the 6 TUR techniques that we're focused on. And so all of our projects need to focus in on using one of these different techniques at a facility to reduce the use of toxic chemicals. We don't want to shift the hazards or the risks or the exposure somewhere else. We want to actually eliminate the issues. There are 3 different TURA entities that work on the Toxic Use Reduction Program. Mass DEP does the regulatory side of the program with regards to certifying planners, helping people with filings, taking in the filings, enforcement and data analysis. Then the Massachusetts Office of Technical Assistance, who does on-site when possible. Otherwise, they're going to start doing virtual confidential technical assistant visits and reports. And then us at TURI, who focuses more on training, grants, research, preparing alternatives assessments, policy analysis, technical support, and we also have a cleaning laboratory and a library as well. So this project that we're presenting on today fell underneath our industry grant program. We're very pleased that River Street Metal Finishing applied for an industry grant last year. And those who are eligible to apply for these grants are manufacturers in Massachusetts who have their main facility that they'll be focusing on in Massachusetts, and they're part of our TURA regulated sectors. Those sectors need to do the reporting and filing and fee paying that I mentioned earlier, and metal finishing is one of those. This particular facility doesn't because they fall under the criteria for the number of employees at their facility. And just to give you a flavor of other projects that we've been working on with other current industry grants we've had going on this year, we've had a facility replacing an NPB vapor degreaser. NPB is what's considered a higher hazard substance under the Toxic Use Reduction Program and is of a priority for us to work on eliminating. Another facility has replaced TCE with a safer solvent alternative and a drying piece of equipment to help them finish their products. Riverdale Mills, who was our first virtual demonstration event, has been reducing several different chemicals by reducing drag out in their process of creating wire mesh. MSI Transducers, they have reduced lead through a new waffle plate design for their process. And River Street, you're going to hear about more today in reducing their use of sulfuric acid. And Plenus Group, who makes soup in Lowell, has done some on-site testing of alternatives to sodium hydroxide that they use for cleaning their kettles. So there's a wide variety of types of facilities that we work with and types of chemicals that we're addressing and different solutions that we're helping them work towards. And that's it for me. There's my contact information if anybody needs to find me. I'm going to stop sharing now and let the folks at River Street share their screen. And while they're doing that, I will introduce them. So Pamela Reeves, with her husband Brian, began River Street Metal Finishing in 1991. She handles all financial duties and I just lost my bio. Sorry, Pam. She handles all financial duties and implementation of the quality management system at the facility. And Lee Reeves has been employed at River Street Metal Finishing since 2007. In addition to production work, he performs many duties behind the scenes, including customer quotes, IT maintenance, and also serves as the in-house chemist performing tank titration. So with that, I will turn it over to you folks.
Okay. Hello, everybody, and welcome to our presentation. Thanks to a grant from TURI, we've been able to purchase and install an acid purification system that's greatly reduced our use of sulfuric acid. Presentation is designed to give an overview of what we do here and to walk you through how the installation of the purification system has benefited us. Next slide. We are a metal finishing company located in Braintree, Mass. We've been in business since 1991, and we service many industries, most of which are located in the New England area. We currently employ 9 people. Our building size is approximately 7,500 square feet, and we are in the process of planning an addition that will allow us to add an additional process line and give us some much needed production space and additional shipping and receiving space. Next slide. In 2012, we became NADCAP accredited, and that allows us to perform work for the aerospace and defense industry. NADCAP is an advanced quality management system that monitors and documents all aspects of our business that affect quality in any way. During the last 2 audits, we've achieved merit status. Our NADCAP accreditation took us years of preparation, and we truly consider it our greatest achievement. Next slide. Oh no, Lee, that's you.
So anodized is our most popular finish that we deal with over here. And anodized is accomplished by immersing aluminum into sulfuric acid and passing an electric current through it. I forgot. So the coating becomes part of the part instead of like a surface coating like a paint or so. And our facility, we're not a big facility, but you start with just a simple racking of parts like this once they come into the shop. And then there's pre-clean tanks, and which would be everything on the right here with the hood. So soap, etch, everything that you need to get the part ready for anodize. And then you move into the actual anodized tanks themselves. This is a type 3 tank, which is a hard coat anodized. And
Tell us what they're doing.
so this is just the way that it's immersed in the sulfuric acid bath and set up to process.
And what are they doing there, Lee?
So that bar is a copper bus bar, and that is the current that is passed through the part in order to achieve the finish. And then down here is the post-processing tanks. This would be like your dye tanks and your seal tanks. The seal is is the final tank that basically closes the pores of the part, so it's ready to go after that. And then, so this is those same parts that you saw on the rack. This is them blue now. It hit the blue dye and hit the seal tank to finalize it, and that's our final product. And to do all that, we use quite a good deal of sulfuric acid. So we have 3 main anodized tanks. We have a type 2 anodized tank, which is 900 gallons. We have a type 3 anodized tank, which is 900 gallons. Then we just added a second type 3 anodized tank, which is 800 gallons. And obviously, to keep 3 tanks running, we need a good amount of, we use 66 degree sulfuric acid. So the tanks are monitored for concentration of sulfuric acid, but they're also monitored for dissolved aluminum. And we try to keep dissolved aluminum in our tanks in a range from 5 to 20 grams per liter. And it obviously goes up faster the more parts you run through the tank. And the type 2 tank seems to climb higher than the type 3 to begin with anyways. So we test for this by titrating a solution from the tank, and it's titrated against the sodium hydroxide to find out the strength of the tank first, and then how much dissolved aluminum is actually in the tank at any time. So, and once we get to our upper limits of our dissolved aluminum, we then, in the past, would bail out 1/3 of the tank, which would be about 300 gallons. So we'd pump it down, and then we'd make it up new to take the dissolved aluminum number from around like 18 or 19 down to around like 12 or 13. And we'd have to do that 2 or 3 times a year, depending on obviously how busy we were and how many things were going through the tank. And so in each time that we pump down the tank, we would have to use about 50 gallons per tank to make up a fresh solution and replenish what was lost. So we were trying to, for a while, I'd been interested in a sulfuric acid purification system, which filters the sulfuric acid. So, but it was never really achievable because it's an expensive system. So we got in contact with Turi, and through working with them, we found out that that would be the best way to reduce our usage of sulfuric acid by, instead of disposing of sulfuric acid solution, we could just filter it and then send it back to the tank. So we began researching systems, and we had one that was from a company in Canada, and but while working with Turi, we were researching all our different options, and we actually found a local vendor in MECChem, and they're located in Mass. And we met with them, and we went over what would work best for our system, and they gave us a quote on a system, and we moved forward from there. So this is actually a picture of the inside working of the filtration system, and it's piped in through. So we have a video. So each tank has a to and a from, which would be here. So there's each tank has on and off valves. So as each tank gets high, we filter one at a time. So those are off right now. And if we wanted to filter that tank, we would turn that on. And so there's a one that's going to the filtration system, and that then it hits the system. It takes a while, but and then it gets sent back up through the other pipe, and we keep two off at all times, and we keep one on. So this is the system. This is me actually not doing much. This is me just fiddle around with knobs because the videographer told me to make it look like I was using the machine. It works on its own. Everything's automated. It will constantly filter everything down and send it back to the tank fresh and clean, and it eliminates our need to dispose of 300 gallons per tank 2 to 3 times a year, which is a great deal of sulfuric acid. So this is just a breakdown of how we're still feeling out the machine and determining how often we're going to have to filter each tank. But this is 6 weeks of us using it on the type 2 anodized tank. So we started with 15.7 grams per liter of dissolved aluminum. And then week 2 was a small reduction. We went down to 15.2. And you can see out over the weeks, we eventually got down lower and we ended up at 11.5 grams per liter of dissolved aluminum, which is a good spot for us, which is where we like to kind of operate at all times. So at that point, our type 3 tank was up at like 14.5. So we turned off the valves for the anodized system, the type 2 anodized, and we switched it to the type 3, so that got filtered down. And we actually just changed it back to the type 2 now. So yeah, so each tank dump would be before the filtration would be about 300 gallons per tank, and then we'd also, so it'd be 50 gallons per tank 2 to 3 times a year, which comes out to about 3 to 450 gallons per tank. We'd need about 220 gallons annually just to replenish what's naturally lost through running the tank. So now we've eliminated the need for that 300 to 450 gallons per tank, and we're left with only needing to add around 220 gallons per year to account for the depletion that happens naturally through just using the anodized tank. So working with Terry, we've saved about 300 to 450 gallons per year of sulfuric acid. And then I will kick this back to Pamela.
So this is our cost analysis. The slide is an illustration of the cost for sulfuric acid that's purchased, or we will call it the incoming sulfuric acid. The left side, which says before filtration system, shows 9 to 12 55-gallon drums. That's about the amount we would be using yearly to replenish the process tanks after tank bales, and the amount we would also need to replenish simply due to production. This again is the before the acid purification system. So with each drum costing $180, we were spending $1,620 to $2,160 a year. So on the right side, we have our expected cost savings after the filtration system, and all we'll be needing is 4 55-gallon drums, and that's to replenish just for natural depletion due to process. And at $180 a drum, we expect to be spending approximately $720 annually. So on the bottom, as is listed, our total projected cost savings should be $900 to $1,440 annually. Another added benefit to installing the acid purification system is that it greatly reduces the accumulation of spent sulfuric acid, or we can call this outgoing sulfuric acid. This is very beneficial to us because we are regulated by the MWRA as small quantity generators of hazardous waste, which allows us to generate and ship out up to, but not over 6,000 kilograms every 6 months, or approximately 1,000 kilograms a month. The picture on this slide for reference shows a 250-gallon tote, which is 1,000 kilograms. The acid purification system allows us to easily remain in compliance with our generated waste limits. Next slide. Cost of savings for sulfuric acid waste, again, outgoing sulfuric acid. This slide demonstrates the other cost savings to us of, again, that of shipping the generated sulfuric acid waste. As shown, the cost to ship each 250-gallon tote of spent sulfuric acid solution costs $767. That multiplied by 4 to 6 totes annually totals between $3,068 to $4,602 annually. And here we've totaled the total amount of expected savings. On the left, we list the amount of savings for sulfuric acid purchased or incoming sulfuric acid, which is between $900 and $1,440 a year. And on the right, we've listed the amount of savings for spent sulfuric acid or outgoing sulfuric acid solution, which totals between $3,068 to $4,602 per year. And on the bottom, we have the combined expected total savings, which is $3,968 to $6,402 that we expect to save per year. Next slide. And this slide shows our return on investment calculations. The cost of the acid purification system was $24,800 and our TURI grant was $20,000. The average of our total yearly savings after having installed the system is $5,005. The return on our investment without the grant would have taken approximately 5 years to recoup. The return on our investment, however, with the grant is 1 year approximately. This makes a significant difference for a small business and gives us another reason to be extremely appreciative of receiving the grant.
So safety is another added benefit to this. So every time you do a tank pump down, you have people exposed to pumping sulfuric acid and moving it, and then when you add to the tank, you're obviously handling the straight 66 degree sulfuric acid, which is nasty stuff to deal with. So it eliminates the need to put employees in the spot where they have to pump down the tank and then remake up the solution that that was lost. So it's better all around. Less encounters with the sulfuric acid means more safety.
And finally, we would like to thank TURI for making this project possible for us. We are very happy to have reduced our use of toxic chemicals, but we're also very happy with the cost savings we'll gain each year. Thank you again, TURI. It was a pleasure to work with you.
Thank you so much, Pamela and Lee. I have a couple of questions here. Can you explain the difference between the type 2 and type 3 anodizing that you mentioned earlier?
So type 2 is done at around 72 degrees, and it builds up at a much smaller rate than a type 3. A type 3 is a much more substantial coating, and it's done at around 34 degrees. So the buildup in a type 3 is usually 3 times the amount of the buildup in a type 2. So the type 3 is a more substantial coating. It's better for harsher environments and holds up to corrosion resistance and the elements more so than a type 2 would.
Great, thank you. You mentioned that it takes a long time for the system to filter the sulfuric acid. Can you let us know how long that takes, and then also how long before you have to replace the filter?
The filter, we haven't got into having to replace the filter yet, so it's a bit too early for me to speak to that. We're still kind of learning the system as we go here, but we found that it's about 6 weeks per tank that we have to keep the filter on the tank in order to make a significant impact on the tank. But since we rotated through all 3 tanks, while the other 2 are in range where we want them to be, the highest one filters down, and we just kind of keep the cycle. We'll know more in, say, a year once we've got a good long look at the effects that it has. But so far, so good, and we haven't had to touch anything when it comes to pumping down a tank and trying to make it up new.
Thanks. And what kind of filtration is it? Is it ion exchange? Is it membrane? Can you tell us a little bit more about the technology?
Oh, that is a good question for someone who's more technical on that than I am. I don't know much about how it filters it. That was Metchem's side of it, the company that we worked with. They designed the system and put it together for us, and all we had to do was pipe it in here. So I don't know. I apologize. I unfortunately don't know much about filtration types.
All right. Can you tell us a little bit more about how do you know when the filter needs to be changed? Like, how will you know? What are you going to be looking for there?
So right now, I don't know if it has to be changed because it filters everything that we have. We can take it out and clean it, but there's a small discharge from the filter, and it's everything that is filtered that comes out. So if I'm correct, I'll have to look into this more, but if I'm correct, I think we can just clean our filter and put it back, because everything that actually gets filtered gets sent down, and there's a discharge from the machine which goes into our system, which is a closed loop system, and we press it down and it turns into sludge, and it doesn't get discharged ever. But that's how I don't think we have to change much when it comes to that.
So it goes to your wastewater pretreatment system.
Yes.
Right. How much does it cost approximately to run the system? Does it and does it run 24/7 or just during production?
It does run 24/7. We keep it on overnight when we go home, just so it has more time to work, because like I said, it is a slow process. And as costs, you would probably know more. It only runs on electricity, so has our electric changed much?
No, it really hasn't, not at all.
Great. So not much of a hit on energy costs. And it also presumably would lead to some reduction in downtime.
Oh yeah, because if we were doing say a tank dump, we'd take a Friday afternoon, and which we could have been using for production, and we'd shut that tank down, and then we'd have to do everything that that was a part of pumping it down and then making it new. So yeah, instead of spending time on doing that, we get to just continue production.
And so the filtration system itself, so we don't know yet how frequently or if you'll need to replace the filter itself, but presumably if you do have to replace it, it would need to be managed as a hazardous waste?
I would probably say so. Just because it's going to be covered in sulfuric acid. So, but like I said, Metchem hasn't. We've been working with them, and so far they haven't said anything about us changing it. We just deal with the discharge that the system creates, and we've been going since February now, and we haven't. It's been working great, and we haven't changed anything.
Right. So have you experienced any challenges with the system?
No, not at all. Not at all.
Easy to install and easy to operate.
Yeah, all we had to do was plumb in the PVC piping with the on-off valves that you saw in the video, and then it just plugs into an outlet and runs on its own. You do have to connect a hose to it so it has water, because it does use water to help it filter everything. So you connect it to that and you're done.
Wow, that's terrific. So I don't see any other questions in the chat, but if you do have a question, please share that with us. We'd love to use this time to answer any questions you may have. So one comment that we had from one of our colleagues at the Office of Technical Assistance is that he thinks it might be a diffusion dialysis system, not filtration. Joy, I don't know if you know about that.
I don't honestly. Yeah, I was looking at those comments, whether it's ion exchange or membrane filtration. I'm not sure.
Mhm.
And I
You
know.
can the Metchem website has, you know, stats on their equipment. They may very well say there what the filtration system is.
Mhm. Good, good. Okay, well, I don't see, oh, here we have a couple more questions. Terrific, hold on. So does the filtration system require a lot of floor space?
Oh no, it's we have it down back with our other pollution stuff, and it takes up it's fairly tall, as you saw in the video, but it's 2 feet by 2 feet deep by probably 2.5 feet wide, and then it stands up straight, and so yeah, not a lot of space at all.
That's terrific, great. Does the filtration system require a lot, oh, I just read that one to you and you just answered it. Let me move on, sorry. What kind of sampling results for dissolved aluminum of your do you get from your pretreatment system? So has it had an impact on dissolved aluminum going into or leaving your pretreatment system?
The pretreatment, as I'm
Your
not sure.
wastewater pretreatment. So has installing this, and I may be changing the question from what the person asked, but has, as a result of implementing this new filtration system, have you seen any difference in the quality of your wastewater pretreatment? So either
So
what's entering it or leaving it?
the system down back that
Mhm.
that we filter everything that goes through the shop, that we have seen a little bit of change. We try to keep it at a neutral pH, and since adding it and you have the little bit of discharge from the machine, the pH has been going lower, so we've had to adjust it and just keep it at a neutral level. But we have normal pH adjustment things that we use, but it's very, very minimal.
Interesting. Okay. And how difficult is it to switch the system from one tank to the next?
You turn off the valves, and I can actually probably,
Yeah, show us.
oh yeah. So just give it 1 sec to, so right there, each tank, you see how it continues on to another tank as it bends around the corner on the right down here. So this is piped into all 3 tanks. This is the type 2 tank, this is the type 3 tank, and then there's another type 3 tank where these lead to. And each tank has these on-off valves, and all we do, those are off right now, we just turn it on and turn the other 2 off. And it's as simple as that.
That's great. Was there much of a difference between the systems from the Canadian company you referenced versus the one in Massachusetts?
I don't know. The one that I was looking at in Canada was we didn't even get deep enough in with them to know what they were doing. We ended up finding the Canadian one's the one I found years ago, and it had put me on to wanting a system like this to make it easier on the shop. And then once we started working with Terry, I sat down to research it again and found Metchem, and just thought it much easier company to work with because they're in Massachusetts and we're not going over the border or anything.
Great. So what would happen if your system was to spring a leak overnight? Is there an automatic shut-off? And how fast is the acid being pumped
It's
through the
being pumped.
purification system?
It's not being pumped fast. So if it sprung a leak, we'd have, first off, it would all be contained in the setup we already have to handle all the waste generated from just daily production. And so it would enter the treatment system, but it filters at a max of 10 gallons per day. So worst case scenario, you'd end up with 10 gallons on the floor and in the system, and it's not the end of the world. There's no automatic shut off for it if it's from a leak.
But very, very slow. Interesting.
Yes.
So let's see, we have more questions about the filter itself and whether the system has some kind of a monitor for pressure drop across the media.
I couldn't answer that.
I don't think it does, based on what I saw. So I have one question here, let me see. Anion permeable membranes allow the acid hydrogen ions to pass through the clean water, which is passing on the other side of the membrane, thereby acidifying the clean water. The metal ions are not allowed to pass through and remain in the contaminated solution for discharge to wastewater treatment. So that was interesting. Thanks for sharing that information from one of our people on the call here. Will the proposed new process line also use the APU equipment? And APU, I'm not quite sure what that means.
Acid purification?
Acid purification? Yeah.
No.
No.
Why not?
Different chemicals.
Totally different kind of a system. All right.
Yeah.
Great. Okay, so can you reiterate what are the concentration of dissolved aluminum set points that you focus on?
So ours are set to operate between a low of 5 and upper limit of 20. And we test it via titration to weekly, once a week, just to see where we're at. And we try to keep it somewhere in that range.
And your sweet spot is?
Well, the lower the better. You need some dissolved aluminum in the tank for the anodized process to work properly, but the lower the better. But we love to just keep it around a normal 10.
Good. Okay. So you said that there is some discharge from the system itself, and if it's a diffusion dialysis type treatment system, that would be the reject from the solution. Do you have a sense of how much of that discharge is being generated?
Yeah, it's very, very small. It discharges into our system, but to start, we kept a 5-gallon bucket under it just to see how quickly it was discharging and what the buildup was like. And after using it for 2 days, we had like an inch in the 5-gallon bucket, so it was very, very slow.
Wow. Okay. Good. And then, so just one comment from one of the people on this webinar is that aluminum hydroxide sludge, if not colored, can be sold. Interesting. However, you use quite a bit of dyes, don't you, in your anodizing process? So does your sludge have color in it?
It's all filtered out. We use a chemical. I saw there's people from Hubbard Hall in the chat. We use a chemical from Hubbard Hall that helps remove the color and make it clear.
Okay. All right. Interesting. And have you encountered any new byproducts with this system? So are there any new issues with what's going to your wastewater pretreatment system? Do you have any other waste being generated as a part of this new system?
No, we're generating less waste because obviously we don't have the 250-gallon totes going out, and but yeah, it discharges slowly. So you have a small tick in the pH level of the the whole system down back, but that's easy enough. And then we press everything to a sludge, and we actually just got a sludge dryer to facilitate lessening our waste even more, because sludge comes out at a certain moisture rate, and we got a sludge dryer so we can basically cut it to a fraction of what it was, because that sludge that comes out of our system down back will now get dried, and it'll be a fraction of the size.
Terrific. Okay. Well, I don't see any new questions coming up in our chat. Let's see, here we go. I just got one. So the question is, do you have a periodic cleaning cycle required, cleaning for the filter itself? And I think the answer is no, that you just let it go, huh?
Yeah, we just let it go so far.
Yeah.
And, well, like I said, we've been using it since February, and we've used it on both the type 2 tank and the type 3 tank. We haven't used it on the second type 3 tank yet, because that level hasn't been at a need yet. It hasn't been high enough for us to worry about it.
The amount of dissolved aluminum in that tank. Yeah. Do you have, is there a recommended preventative maintenance schedule for the filtration system?
No, nothing that when Metchem went over a lot with us. They spent a good couple hours down here with us showing us the ins and outs, and they didn't have much to say about preventative maintenance. It just kind of operates.
Great. Let's see, have you seen any increase in the amount of sludge that's being generated? I think you just answered that, didn't you?
No, maybe. No increase in sludge, no.
Yeah. Good. Okay. I'm trying to see if I've missed anybody's questions. Lots of really good, intelligent questions in here. We have one comment from one of the people here saying that that membranes may have to be changed out every 4 to 5 years, or the performance may decline. So something to keep in mind.
Yeah,
And
absolutely.
certainly, check in with your vendor on that.
Yeah.
Cool. Great. Well, Joy, I don't see any other questions.
Yeah,
Pamela and Leave.
Yeah, looks good, guys. I just want to say thanks to everybody for joining us for the virtual demonstration event. It was really neat to be able to see, what goes on at the facility through the videos, and to hear from you guys how it's working for you. So, and as well as the cost analysis. Really appreciate your time. Really appreciate your diligence on the project, and it's been a pleasure working with you all.
It's been a pleasure working with you as well, Joy.
I think we're all set, Pam.
I think we are. Thank you all for joining us. Have a wonderful day, and we will be posting the recording of this session on our website in the next few days. Have a wonderful day, everybody. Bye-bye.
Thank you.
Thank you.
Bye-bye.